Hey YouTube, warbles on a lot here. Those of you familiar with the channel will no doubt remember that I've showed this little Peltier-Effect powered fan before, and I've even put up a video, waxing eloquent, regarding the clever production engineering involved in manufacturing this one-piece stamped sheet aluminium fan. As you can see, I've given it a little squiggle, rather like they put on the spinner hub of a jet engine, so that I can count the revolutions. And I think this thing's doing 300 to 350 revolutions per minute when it's operating happily on top of my pot belly. But because it's painted matte black, it's actually fairly difficult to get your head around the aerodynamics of what's going on with this thing. So I had to substitute the clean sheet of paper method. Here's what it actually looks like. And as you can see, the inner part doesn't really do much. You've got from here around to here, and then this is the fold line. And that fold line means that, well, a large part of the blade isn't really doing much. And when you consider where the curvature makes itself felt along the blade, and yeah, I've color coded this, you can see that you've got an 8-degree angle of attack out there near the tip, 6 degrees in towards the inner edge of the effective part of the blade, goes down to 4 degrees. That would be 4 degrees, 6 degrees, 8 degrees along that line there. Now, it might be an interesting piece of production engineering, but I don't much like it in terms of airscrew design. So, yeah, I had to come up with something better than that. So, about the only figures that we've got is that according to the box, this thing is apparently good for 150 cubic feet per minute of warm air. It's an 8-inch diameter fan, which is doing about 300 revolutions per minute. We feed those figures through the calculator, and we need a 6-inch pitch for the 8-inch diameter to get our 150 cubic feet per minute. And a scale drawing and a ruler and a protractor gives us our pitch angles at the blade stations. There at the hub, 67.5 degrees. Blade station 1, 43.5 degrees. Station 2, 25.5 degrees. Station 3, 17.5 degrees. And out there at the tip, 13.5. And that shows the overlapping of the laminae. So the next trick is to do the working drawings on the wood. This is the actual paper plan, but the working drawings, they happen on the wood, and then you chop the wood up and then you glue it back together. And that's about where we are at the moment. This is cedar and black oak. Haven't even started carving it. It's not a perfect blank, but it's not too bad, considering that I haven't tried to make a laminated propeller for about 26 years. And that was a full-sized one, so I had to think really hard to try and make one on this scale. Didn't go perfectly well. This top laminate got a little bit squashed. I used too much pressure on it, but it doesn't really matter because nothing past there is going to actually be in the finished propeller. As you can see, that top laminate, it's gone from there and it's gone from there. It's only got to be there for that and that and that, which is that and that and that. So having it squashed out here doesn't matter. But anyway, small things amuse small minds, and I am seriously determined to have a bit of a go at competing with the Chinaman's production engineered sheet metal fan in cedar and Banksia. Well, not Banksia, Casuarina subrosa, mountain or black oak. But I may not achieve optimum efficiency on the very first go, but I'm pretty bloody sure that this together, as rough as it's going to be, is going to be a whole lot more aerodynamically efficient than that, unless I miss my guess. I know it's cheaper and faster and easier to make a pressed sheet metal fan, but I think this is going to be more pleasurable to watch in operation. Okay, so the stove's at 18.5 degrees Celsius at the moment. The base of the fan is at 18.7. We light the pot belly. And we're looking at 7 o'clock. Okay, 7:05. Pretty close to 200 across all over there. 112, 113. There we are, now you can see where the dot's pointing. Got to be 80 degrees. By the way, that's how you pick it up. It's got a little retractable handle. There we That ought to be pretty good. And you'll get a real-time indication of how long it takes for this thing to start working. And I don't know for certain that my first or second or even third attempt is going to actually outperform this thing, so that's why I got as much wood out and sanded as much as I did. I may have to make 2 more 2-bladed rotors, and then I'll have a go at a 4-bladed rotor, and if I get really, really ambitious, I might even come up with a 3-bladed rotor. Okay, so I'm going to have to back off that to show you what we're looking at. 88, 90 degrees on the bottom of the mounting. I would say it'll start moving pretty soon. $118, 125 at the back, 103 at the front, 35 degrees on the top of the cooling fins. There we go. And for the fun of it, put a strobe on it. Try with a different camera angle. Once again, infrared, for some strange reason, comes out as blue on this phone. Well, that doesn't help. And nor does that really. But anyway, that's the opposition. That's what I'm trying to beat with my Aero Hillbilly Enterprises laminated helical cedar and black oak Airscrew. And yeah, of course, This too is a mad scientist video. Warbles on a lot to YouTube. Ciao.